today I have something that may seem as a petty complaint, but it truly isn't. It is something that I think is very important in order to design a very good programming language, and I don't see anybody talking about this problem. And that is syntax. We tend to think of syntax in programming languages as just this collection of absurdities, right? Of conveniences that you just put in there because, I don't know, it's convenient for the programmer to type less or to be able to express whatever. So it's like Python, right? So you type the Zen of Python and you get the write less. The language is supposed to be expressive, blah, blah, when it truly isn't. You have no guarantees of anything. It's truly a pile of garbage. The idea here is that just to give you some context, I'm writing this database kernel. Think of it as an analogy for a operating system kernel, but in a database. So we are porting a C++ code base to an OCaml rewrite, and there is this in OCaml you basically set expressions because it is the tradition from OCaml and camel in that case comes from ML, and ML follows lambda calculus. You come up with this. They came up with this. So this is a let-in expression. So you're basically setting a name for the variable and an assignment for whatever expression you may want that variable to represent. So this is not truly the same as, I don't know, a variable in, say, C, right? So the idea here is that you have something that is more like a function. This is more like a lambda, right? So if you think of lambda calculus, you don't have loose expressions of variables going around. You have just variables that are to operate under substitution, right? So you don't have this idea of assignment, you have substitution. So substitution is your evaluation semantics, where you basically throw things at it and replace them on the runtime. So the idea here is that you can do things like, for example, set a lambda that describes that expression, descriptor, blah. So something like this, right? So that would be the equivalent of this expression, but something now that you can invoke. So you would have this as an object, and now you can invoke this guy. So the idea is that this let in is evaluating this expression in the scope of the next expression. So it's as if you're just nesting those functions, right? So you could nest them like this. That would be cur.open, blah, blah, handle. Of course, that is also a variable, but ignore that for my argument. And then you would do something like this, right? Something like this. So you're just nesting those guys together. So that's more or less how you could interpret this. So this idea, but this, of course, is a very convoluted syntax to express that. So people came up with this idea of making things with variables, and then you just declare them, and then you evaluate. Now, the point of a syntax is to reflect exactly this division between, is to reflect exactly the intent that you want to convey with the semantics of the language. So, for example, here it's a lambda calculus language that has all this baggage, so you're not going to represent it the same way as you would represent C, that is following a completely different tradition, right? You're following like almost a better copy of assembly in that case. So a better abstraction on top of assembly. So you're trying to express the von Neumann machine in a better way, in a more abstract way, but it's still the von Neumann machine. There's no concept of the von Neumann machine. I mean, there is, but it's more like there's this magic box that operates under the lambda, and you're just making expressions on that thing, and it returns back to you, right? So it's this abstract architecture that we're talking about. So the language tries to convey that. And in order to notice the separation OCaml does, you can see that these expressions here, for example, they're just bindings of labels to other expressions, but they are in the scope of a module. So under a signature of this module, you have expressions like these vols, right? So these are, for example, values that you have in a module. And these are just binding values in the scope of the module. So notice that there's no in here, because you're not evaluating to the next expression, you're evaluating to the module. So you can clearly see on this function, because this here is a function that doesn't have the in at the end, like here. But the internals of the function do. And that is the magic of a syntax. So let me give you another example to make it absolutely clear. So in Lisp, you can set the identity monad as a let, right? So you would have basically a monad with the identity function. It's this. So you would have b2. And then you can do plus ab. That's 3. So cool, that is just eLisp being evaluated, like Emacs Lisp. Now, the idea here is that you have a list. Why do you have a list of lists here? Because you're binding this value, and each list inside of this list of bindings, each binding is a set of 2 elements where you bind the first guy to the second guy. That's basically it. Now, in Clojure, this is slightly different. Let me actually do this. So in Clojure, it's slightly different. You use actually the notation of a vector to do this. I can't evolve because I'm not in the Clojure mode, but so this would be the way that you would set. But notice this is just by convention that I'm putting on the new line, but you can do this, right? So by convention, I would look at the thing and evaluate pairwise. So value on the label, expression, label, expression, label, expression. And in fact, you can do a lot of structures like this in Clojure as well. But the point is, the idea here is that a map, I think you can do that way. It's been a long time since I've done this, but I think you can do this with a map as well. So like key value, key value. You can put additionally a comma to it, but it just like the reader just gets rid of the comma. So anyway, the idea here is that you have one expression, one element, one object of your language, that is the vector, that you can read and interpret differently from the rest. So the idea here is that you will read inherently, you will read this guy, come on dude, stop this. You will read this differently from what you would read, say, this, right? You will read those 2 things differently. Now, the thing is that when you do so, at least this is giving me, from the context of the let, I know it will operate this way, and it's a consistent interface on the language, right? So this is not, I'm not saying this is necessarily bad. It's just giving me another way to do exactly that. But there's other languages that abuse this, like for example, JavaScript. JavaScript is, the syntax is absolutely atrocious because it's trying to represent something that it isn't, right? It's trying to represent this C-like language on the browser. JavaScript was supposed to be a scheme, right? An interactive language, more or less. And then it ended up like that because, well, Java and C were popular in the 90s. So, and the argument was familiarity, right? So people would get familiar with it. They would immediately jump, and they did. But I think that's just an argument for the worse is better. Now, the point is, I'm writing this language here. It's called Sol. Let me pull that up. And I think it's on the docs, language specification, here. So I'm writing this specification for a language. Sol is essentially a language for my OCaml project. So the idea is to make a non-Turing complete language, like intentionally non-Turing complete, where you can check totality. And that's already good enough to express a lot of problems that you may have with database design, and ensure that you have termination, right? Which these languages like PL, PGSQL do not give you as a guarantee. You can make arbitrary recursion and then you shoot your food. So it's a massive foot gun that I want to get rid of. And the idea here is that Sol is supposed to have a syntax. Let me see if I have one here. So the idea is that you have a syntax that is uniform throughout the language. And I came up with the idea of mixing Prolog with Smalltalk. So this is more or less how it looks. So you would have something that is a relation. So integer is a relation. And then you have a value that you want to bind and unify with this label of this relation integer. and then you have a person, and then you have a plus relation, like a function, right? The plus relation, a person, and so on. So the idea is more or less to attempt to represent with some level of uniformity what most languages just throw out of the window, right? In F sharp, coming back to my OCaml example, F sharp completely just threw this off the rails when they got rid of this. So they literally got rid of the verbose syntax, because F sharp in the beginning was a OCaml for the .NET, right? Now they're their own thing, so they got rid of this verbose syntax. You can still type it, but it will, like, I'm not sure if it will issue a warning, but certainly the formatter will get rid of. So there's not even a tag anymore to allow verbosity or enforce verbosity. So the idea is that the language gets rid of those things. And now, what does it look like? It looks like you're just making a loose binding, and you are mixing two different categories of this guy and this guy. They're not the same thing. And I think, like, it's much, I think what I'm trying to say here is that a specification for syntax is not just arbitrary. A syntax should represent an assent with the perception that it causes by evaluating a term and making any operation really under a set closed world of assumptions, right? Because when you are in a language, you are in a mode of thinking. That's why Lisp, I think, is great, because you can morph the way you approach the problem. And here you are basically, like in most languages that you don't do this level of metaprogramming, you're bound to the abstractions the language offers you. So when you are bound to those expressions, to those abstractions that the language limits you to, it's for a reason, right? It's supposed to have a motive behind those the selective few abstractions that are being shown. So if you're just making arbitrary, like syntax, coming up with stuff just to justify and make special rules and cases, that's just bad design. That's not conveying what the mental model should be, and not bringing awareness to what each statement should represent. So anyway, that's my point. I'm gonna write something about this later, probably more qualified with like quotes and etc. But I think that's the idea. And that's it. That was hopefully this was not just a petty complaint, although this really drives me mad. Bye bye.